Good morning. This is segment one of section 2.3. This is the generally the first section that we cover in the second course unit. So to kind of preface things, we've looked at some parts of triangles. I think that it's foolish to think in this modern age that that you can ignore the use of calculators in a class and still have any sort of reasonable application. When I took trigonometry a while ago, you didn't typically calculate the trig values of strange numbers. And the reason why is that you had to use tables, which is kind of a complicated process, involves interpolation. You have to be able to do, 2 points to a line and then approximate, blah, 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 blah. So anyways, it was not very conducive to do a lot of those kinds of calculations, like say finding the sine of 23.8 degrees or something like that, because it was very challenging to get there anyways. So you do it a couple times just to practice, and then you just forget about it. However, the proliferation of scientific calculators in the last 30 years has made it such that it's pretty reasonable to expect that a person can use a calculator to calculate a trig function and use that to solve more real world application triangular solutions. So let me just say right from the outset that there's a couple things that you have to know about a basic scientific calculator. So if you take a look at one, and I'm going to go ahead and shift over the document camera. I've got a TI 30XA, which is probably, I mean, it's a good middle of the road calculator. It's probably about my favorite because it's complicated as it needs to be, but simplistic. So if you take a look at this, you have a couple of different features I want to point out, and I apologize that the lighting isn't real perfect here. But first off, notice that you have your sine, cosine, and tangent buttons here that allow you to, in this particular calculator, you punch in the angle measurement, and then you click the button for sine, cosine, tangent. There are other functions that there are other calculators that work on order of operations. You can type out whole big long strings, but like I said, this is not a complicated calculator. What I do want to point out though is that there is no secant, cosecant, or cotangent button. So even with such a sophisticated device as this scientific calculator, you still have to know some of these fundamental identities to be able to adequately calculate values of trig functions. So there's also something to be pointed out, which is that these calculators usually have different angular modes. And if you look right up here, it's kind of a little hard to see, but right now this says DEG, which means that it is in degrees mode, meaning that when you punch in an angle, it's expecting that angle is an angle measured in degrees. There are other modes. For example, there's something called a radian mode. And when you click this button, it cycles through the different modes. Now you're in radian mode. Now we won't talk about radians until chapter 3, which is right around the corner, but it is a different mode. And sometimes people will have, as you switch between modes, people forget to change that and you end up with really, really bizarre answers because you're punching in numbers that you think are right, but they're not. And then usually there's one other mode called a GRAD, which is a gradient. And I will tell you that gradients are used in Europe to some extent. Most survey grade measurement equipment can run in gradients, but this is something that in the United States is used hardly at all. I can't even think of a good situation where you would need to know that. But basically, the difference is that a gradient, there are 100 gradients in a right angle. So a full circle is 400 gradients, just like a full circle is 360 degrees. Anyways, that's useless information that you can file back for, whenever you appear on Jeopardy. but for our purposes, it is completely irrelevant. So there's a quick way if you're not really sure whether your calculator is calculating correctly, you can just try a known value real quick and just to check it. And usually what I'll do is I'll take the sine of 90 degrees. So if I'm thinking, let me just do a little test run to make sure my calculator is working right. If I take the sine of 90 degrees, it should be 1. Now, if I happen to be in radian mode or some other mode, and I tried to do that same tactic, I'm going to end up with something that's completely different. So there's the sine of 90 radians. And if you do it with gradients, you'll get it with something similar. So just always make sure as we continue through the semester, we will be switching between modes kind of fairly frequently. And so you got to make sure you're in the right one. Now, also, since you've had the test over degrees, minutes, seconds, and some of these other versions, I want to also point out that most calculators have a way to automatically convert from decimal degrees to degrees, minutes, seconds, or vice versa. This calculator does, and it's pretty slick. If you look down here on the bottom, you have this DD with an arrow DMS. And when you use the second button, what that does is it'll take something that's typed in degrees, minutes, seconds, or typed in decimal degrees, and will convert it to degrees, minutes, seconds. And then right above it, you can see there's another button that's DMS to DD. So you can't really tell if you're in degrees, minutes, seconds when you input them, but let's just take an example. So if I had, let's say 20 degrees and 30 minutes. So we know that that's 20.5. That's why I'm kind of pulling it out. So I've typed this in with a period. That's just the cadence and the syntax that this particular calculator likes. Other ones, you put them in different ways. But then you've got this little mode down here where I'll hit the second button and degrees, minutes, seconds to decimal degrees. And notice the output is 20.5. If I were to do something else, like let's say that instead I've got a decimal degree of, let's say 21.82 degrees. So 21.82 degrees. And I wanted to find that in decimal, in degrees, minutes, seconds. What's the other button? Second, DMS. And here's the one and only place on this calculator where it displays degrees, minutes, seconds. Different calculators will be better or worse at doing that. So you have to really be kind of cognizant of where you're at. Now, why do I spend so much time talking about degrees, minutes, seconds, and their conversion is because a lot of the problems that you encounter, especially in chapter 2, at the end of chapter 2, have their measurements, the measurements of angles in degrees, minutes, seconds. But when you use these trig functions on these calculators, it does not know what to do with something that's typed in as a degree, minute, second. Even if you're in degree mode, you have to have it in decimal degrees. So in many cases, you're taking your first step is to convert something and then take the trig function of it. So let me just with all that sort of extra preamble there, let's take some examples. So section 2.3, page number 1. Now, again, the only time that we're going to use a calculator is if we don't know the exact value, right? That's why we spend all that time on exact values. If it's something that's, if a problem says find the exact value, it means do not pick that calculator up. Those numbers are necessary. Anything that comes out of those is almost necessarily an approximation. We haven't really talked about how to round properly, and that comes up in section, I believe it's 2.4, where we talk about significant figures and things like that, which is more of a scientific concept than a mathematical concept. So for the time being, if a question asks you to write down all the numbers, then you write down all the numbers, and that's usually what happens. So let's run through a couple of examples. So let's say find the cosine of 39 degrees, 12 minutes. How about the cotangent of 37.168 degrees? How about the secant of 18 degrees, 42 minutes, and 30 seconds? And say what we got. Okay, so they're going to go from easy to hard here, harder. I mean, they're all basically the same. So in the first problem, one of the first things that we're going to want to do, and remember, this is because of the syntax of this calculator. Other calculators may do it in a different way. The angle is given in degrees, minutes, seconds. But remember, this calculator will not compute the trig functions using degrees, minutes, seconds. It has to be in decimal degrees. So typing in 39.12, this is when I convert from degrees, minutes, seconds to decimal degrees, this is how it understands that the number before the period is the degrees, the next two numbers are the minutes, and then every number after that is the seconds and decimal seconds. That's kind of how it works. So 39.12, I'm going to convert from degrees, minutes, seconds to decimal degrees. And there it is, it's 39.2 degrees. So if I was going to maybe kind of write down what I was doing, show my work, so to speak, this is the cosine of 39 degrees, 12 minutes is equal to the cosine of 39.2 degrees. And then I just simply take the cosine of it. So I end up with this number that, I mean, that is an irrational number. It's not going to repeat at some point. It just keeps going and going and going. So this is an approximation, but it is approximately equal to 7.7494448.9. Okay. And until we know how to round them, that's sufficient. And some calculators have more digits or less digits. Realistically, you don't need very many of these, but so be it. How about part B? So the cotangent, in this case, finding the cotangent of 37.168 degrees, I don't have to convert this, right? Because it's already in decimal degrees. But this is not, cotangent's not a button on my calculator. So I do need to use a fundamental identity first, which is that cotangent of 37 degrees, 37.168 degrees. Now, probably I could use a reciprocal function or a reciprocal identity to turn this into tangent, but why not just use the cofunction? That way I don't have to worry about taking 1 over. So in this case, is equal to tangent of 90 degrees minus 37.168 degrees, which is simply equal to the tangent of, what's that? That's going to be 52.832. I'm going to check my mental math there. So 90 minus 37.168, yeah, 52.832. And now I'm going to simply take the tangent of that, which is this kind of strange number, 1.31, blah, blah, blah. So 1.318980363. And again, we don't know how many digits are really appropriate. It's based on a measurement, etc. So this is a quick way to do that. Now, I'm going to combine both these in the last problem where we have to do not only a conversion, but also some kind of a fundamental identity as well. So the first thing is, let me just kind of do some things involving fundamental identities. So this is going to say, we need it into either, we need to be able to write that as either a function of sine of some specific angle, cosine, or tangent, and it needs to be in decimal degrees. So the easiest one to use is probably a reciprocal identity. So secant of 18 degrees, 42 minutes, and 30 seconds is equal to 1 over the cosine of the same angle. So 18 degrees, 42 minutes, 30 seconds. Now, again, this is not particularly useful because we can't take the cosine of that angle either. So we could do the conversion, but it's much easier to use a calculator. So let's take 18 degrees, and then remember the decimal place is going to, when I'm going from degrees, minutes, seconds to decimal degrees, is saying the first two, whatever's in front of the dot is the degree part, and the next 2 units are the minutes. So 18.42, and then everything else will be arc seconds and decimal arc seconds, so 30. Now I want to convert from degrees, minutes, seconds to decimal degrees. So there's the decimal equivalent, which notice it has sort of a repeating decimal. I don't want to round that off. I just want to now just hit cosine of that. So I'm taking the cosine of that angle. And remember, I'm not interested in the cosine, I'm interested in the reciprocal of the cosine. And so I'll just use this little button here that I can sort of flip it upside down. And there is the value, which is approximately equal to 1.0557837775. And there's an infinite number of digits because it's an irrational number. So I don't necessarily want to belabor this point, because I think that this is a relatively easy concept for students to do. I think most students can either have done this before or they know what's going on. The only thing to be careful about is when we have to involve these identities and when we have to convert the angles from some form into a more usable form, specifically degrees, minutes, seconds to decimal degrees. You got to remember all those details. It's kind of the thing. So I think this is probably good for this segment. What we're going to move into next is we're going to go the other way, where we say, well, what if I know a value? How do I find an angle, right? Like if I knew that the sine was 0.688 or something, how would I figure out what angle is associated with that? And that's a little bit more complicated problem, which requires us to talk at length about how inverses work. And it's not something super trivial. So we will look at it for acute angles only. So we'll only be looking at inverses that produce acute angles, possibly negative, but either quadrant 1 or quadrant 4 angles. And then we will probably take a look at maybe some kind of an algebraic formula that maybe has a trig function in it, and use that to solve sort of a basic problem. Okay, so I will see you again in this. Probably we'll only need one more segment, but I'll see you in the next segment.